Hi, Elerias. In this video, I'm going to be showing you a little trick of mine to be able to identify oxidation numbers and valencies of elements. Before we start, what do we mean by valencies? Valency is simply the combining powers of elements, right? So when a particular element is reacting with another element, they have certain powers in which they combine to form a compound. So those powers are called the valencies, and those powers they range from 0 to 4. So these are their valencies. The valencies can be 0, 1, 2, 3, 4. They are called the combining powers of elements. Now, what are oxidation numbers? Oxidation numbers are these valencies or this combining power in respect to the charge. So differences between valencies and oxidation numbers is that oxidation numbers just show the power of the combination, but oxidation number shows the charges. So if it is 1, it can be -1 or +1. If it is 2, -1, -2 or +2, as the case may be. Now join me, let me show you the trick in which I use to get oxidation numbers of elements. Now, on the board here, I have lithium. How can I get the valency of lithium and the oxidation number? I simply write the electronic configuration of lithium. If you don't know how to write electronic configuration, check my previous videos. You will see the step-by-step way of writing electronic configuration. Now back to this. The electronic configuration of lithium is what? Since the atomic number is 3, lithium is 2, 1. What about the boron? 5, 2, 3. And carbon is what? 2, 4. Fluorine is 2, what? 2, 7. Neon is 2, 8. Magnesium 2, 8, 2. Phosphorus 2, 8, 5. Chlorine 2, 8, 7. And calcium 2, 8, 8, 2. So like I said, if you don't know how to write electronic configuration, check my previous video to see how I taught the electronic configuration in a very simple term. Now let's continue. Now how do we get the valencies of these elements using their electronic configuration? First of all, we have to ask ourselves, what will lithium do with its valence electron, its outermost electron, in order to have 8 electrons in the second shell or 2 electrons in the first shell? Why are we concerned with 8 electrons and 2 electrons? Because this is a concept called the octet state. Every element is trying to attain this octet state, having 8 electrons in the outermost shell or 2 electrons, which is duplex state, 2 electrons in the first shell. So what will lithium do? Simply, lithium has 2 options. It's either it will lose its valence electron, which is 1, it will lose 1, or it will gain 7 electrons. Because if you lose 1, it's going to have 2 electrons in the first shell, which is duplex state, or it will gain 7, which will be 8 electrons in the second shell. So which of these is easier to attain? To lose 1 or to gain 7? Definitely know that losing 1 will be easier for lithium to do. So since losing 1 is easier for lithium to do, that means that 1 is the valency for gain 5 electrons, adding to this 3 to make it 8, octet state, or it's going to lose 2 in order to have 2 electrons in the first shell, duplex state. So which of these numbers is lesser, meaning it's easier to attain? To lose 3 is easier to attain, right? So losing 3 becomes the valency of what? Of boron. Now, what about carbon? Carbon, same thing. It has just one option. It's either it lose 4 or it gain 4 electrons. So the valency of carbon is what? Alright, so what about for fluorine? Fluorine has 2 options also. It's either it loses 7 outermost electrons or it gains 1. So between these two, which of them is easier for fluorine to attain, or which of them is lesser for fluorine to attain? So gaining 1 electron to its outermost electron to make it 8 is better than losing what? 7. So that makes the valency of fluorine to be 1. Now what about for neon? You can see neon here is a noble gas. It already have 8 electrons in the outermost shell. Like I said, or like we all know, noble gases are always stable. They don't work, they don't react, right? So the combining power of noble gases are always 0, because it doesn't have any option either to lose or to gain in order to attain the octet state, because noble gases already have octet state. So the combining power or the valency of neon is 0. Is that okay? Now what about for magnesium? Magnesium having 2 valence electrons has 2 options also. It's either it loses its valence electron or it gains how many? It gains 6 in order to become 8. So between 2 and 6, which of them is lesser or which of them is easier to attain? Which is 2. That is to say that the valency of magnesium is 2. If you really understand this, solve or get the valencies of the remaining elements, phosphorus, chlorine, and calcium. Drop it in the comment section, and I'm going to see you in the next video where I'll be talking about how to get oxidation numbers. Bye.